All right, we good? Cool. I think people are still trickling in a little bit, but I'm going to go ahead and get started. This is No More SQLite, How to Write Tests with EF Core Using Test Containers. My talk title is so long I can't remember it. I'm Daniel Ward. If you are curious about downloading the slides yourself or looking at the repo I use in this talk, that's what the QR code takes you to. If you prefer to take pictures of the slides yourself, you can still do that, but just so you know, this QR code will let you download them. This will be on the ending slide as well. And to sort of explain what the mouthful of the title is, I want to start with a short story. And so stop me if you've heard this one before. A couple years ago, I was on a team and we were making a web API in C#, and we have a Postgres database for our backend that we hit. And we're making new features, everything's going good, and one day we're making a new feature, and like any good, obedient team of devs, we have a test suite, right? And well, first, is everyone here writing tests? Show of hands. Is anyone here not writing tests? Yes. Don't admit that, that's embarrassing. But, okay, so we're all writing tests, right? We have our test suite, including integration tests. And for that, we use SQLite, the SQLite provider, just because I think it's what we were all familiar with, which is what we had experience with. It's easy to get up and running. So there wasn't a whole lot of thought and discussion put into that. We just use a SQLite provider to get up and running with our integration tests. And this new feature we're making, we finish and all the tests pass, everything looks good. And then, of course, once we get into production, what happens? We get an error in the logs eventually. And we fixed it eventually. This was very confusing and very frustrating if you've ever come across one of these errors. Ultimately, it was because there was some difference between SQLite and Postgres that whatever query that EF Core generated just didn't work the same between them. So it worked fine on SQLite, and then when we ported it over to Postgres, it did not work the same. So we got an error in production. And it's sort of like, you know that saying, people don't remember how you treated them, they just remember how you made them feel. It was sort of like this. I don't even remember what the query was anymore. I just remember how EF Core made me feel, and it made me feel bad. I didn't like it. We're on good terms again, but we sort of have a mediator here, and this is test containers. So ultimately, the problem was Postgres or whatever database you're using in production, SQL Server, MySQL, whatever, and SQLite have a large amount of overlap, right? I would not be surprised if it was 80 or 90%. But the danger is when you get into these no man's lands over here. And Postgres has a feature that SQLite doesn't. Maybe they have the same feature, but they just work differently between them. What's really confusing is if one has a bug and the other doesn't. And somehow you just don't have feature parity between them. And I think this took us about 2 days to figure out what was going on. These are very confusing, a bunch of searching, just error messages until you finally stumble across something that says, oh, this just isn't in SQLite, or this is in Postgres, but it works differently there. And then finally, you can start to address that. And then even then, you have to decide, well, I'm going to have an if statement in my code if I'm in the test or not, so it runs differently. And then really, I'm testing something else at that point, right? So we have this whole problem with false positives and false negatives, where in our case, our test was passing, but really, it was the wrong, it was a lie. It was not working in production. You can have the inverse too. Your tests on SQLite can fail when really maybe you would have been fine to deploy and it would have worked just fine on your production database engine. And ultimately, the problem is if you only take one thing away from this talk, if you remember one thing, I want it to be this slide, is that if you are using another SQL engine in your tests than what you're using in production, you're testing another system. It might be a similar system, it might be pretty close, but it's not the same thing. You're testing something else. So it'd be like me saying if I'm manufacturing a car, I said, all right, we're almost ready, we just got to do the crash test now. And instead of doing the crash tests with my car, I take a car frame, and not even the same car frame, something similar, and I do crash tests with that. And I say, all right, everything looks good, we're all good to go. That's basically what we're doing with SQLite. And I have the crash dummy over here on the right, because that's what I felt like for doing that. Okay, and ultimately, why does this matter? Why do we care about all this? Debugging our tests, getting things wrong. Anyone take a guess? Starts with M, ends with UNI. It's expensive, right? I would say the vast majority of the time, maybe there's exceptions, the most expensive part of any software system is going to be you. It's going to be the developer. So if we say on average, if you're $100K a year salary, you get paid $50 an hour, that's going to be vastly more than any single cloud service or anything that your little app uses, probably. So the longer it takes for the dev team to debug something, it costs the company exponentially more money. Not to mention, these specifically are just extremely frustrating to figure out. So I've kind of given you the problem here, but not the solution yet. I'm going to talk about me for about 30 seconds. I'm a software developer and consultant for a company called Lean Techniques based in Iowa. I'm a Microsoft MVP in .NET. I'm the co-organizer of the San Antonio and Austin .NET user group. So if you're ever down in that area, hit us up. And you can find me online on the socials, and I have a technical blog at danindacan.com. So especially if you found this talk useful, if you have any feedback or anything, please hit me up on any of those. I'd love to hear from people who found me from stuff like this. Okay, so you might say, cool, Daniel, but I'm not actually using SQLite. Maybe I'm using an in-memory provider, or I'm using a real database out there or something. And I think this pretty much covers these 4 things, all the traditional options you usually see when integration testing. And so we talked about the SQLite provider. I think the EF in-memory provider is like the SQLite provider, but worse. I think on the MSDN docs, they even straight up tell you, please don't use this. I'm not sure why it's there, honestly. It has the same advantage of the SQLite provider in that it's easy to set up and get up and going and write tests, but it has the disadvantage of it's not even a relational database. It can't support raw SQL or transactions. It's basically SQLite, but with less stuff. And then SQLite obviously has the problem of not being the real thing. Something I've seen before also is to use a real database out there, and this works. The good thing is you are actually using the same database engine as your production app. The disadvantage is you're essentially setting up an entire environment you now have to maintain just to run integration tests. And you have to figure out, you can't run more than one suite of integration tests against this at a time, or else you get duplicate data. You have to make sure the data gets cleaned up correctly. You have to make sure, if it's a whole separate database, you have to make sure it gets the schema changes that that real one does at the same time. And you can get around all these things, but if it sounds like a lot, it's because it is. It's a lot to maintain and keep up and running and make sure it's working. And finally, there's Docker. And I think this is a pretty good option, honestly. It has the advantage as the last one in that it's the same engine, right? But you don't have to worry about cleaning the data. It just spins down when your tests are finished. Really, the main issue with this is that you have to maintain a Docker file in your repo, and you do have to maintain the container lifecycle a little bit. Make sure it does spin down correctly when your tests are done, things like that. And that's basically how TestContainers started. It started in Java about 8 years ago, I think. And they said, we are using Docker for our integration tests, and this is awesome, it's working. But there's kind of a common set of tasks we're doing almost every time, because we're addressing the same problems every time. So can we kind of, take this and automate it and boil it up as an API instead of having to manage a Docker file and all this? So you just don't have to do this every time. You can shorten the workflow. And that's what TestContainers is. So I think databases is probably the most common use case you're going to see for this, and that's what I'm going to show in the coding demo. But it's basically anything you can containerize will work with this. So this is not an exhaustive list. I've just thrown some icons up on here. It works with Kafka. You can set up a Redis cluster with this, with RabbitMQ. We're going to use it with Postgres, but it works with all types of databases. You can give it a custom image if you want, if you have something else already running in production that's super custom. Same thing with the languages on the left. It's not an exhaustive list of them. But the nice thing about this being written all these languages is that it's transferable knowledge you can bring with you through your career. So if you go to a different team or company and you're not on .NET or whatever anymore, you can still use this and maybe try to pitch it at your next job. So this is straight from the TestContainers documentation. The whole process for how it functions is pretty straightforward. You have setup, you run the tests, and it closes down. When you set up, it spins up containers with whatever you've requested. In the demo, we're just going to do Postgres container, and that's it. But you might set up multiple things depending on how complicated and how involved your integration tests are. You might want to put the queue in there. You might want to put, this has Elasticsearch. And then it runs the tests against those containers. And when the tests are finished and the cleanup happens, it just automatically spins them down and gets rid of the volumes, networks, and all that stuff for you. So one of the things with SQLite, an EF in-memory provider that I mentioned, is that they're very easy to get up and running. That's what people like about them. And that's true. That's why I used to use it. And with test containers, especially compared to Docker, it's pretty simple, because this is what it takes to get it up and running in your tests. It's one line to set it up, one line to start it, and one line to throw it away. And that's pretty much all you have to do. Obviously, there'll be a little more setup if you're using more images or something. But this really is pretty much it. And that's what we'll see in the demo as well, which we will go ahead and go over to. So I've got a pretty basic app here. It's just an API for, if you imagine like a fictional bookstore. Is this text big enough for everyone to see, by the way? Good, cool. And we've just given people the ability to, you can like a book and you can leave a review on a book. And you can get a book as well. And all this logic is stored in this book service, which is really not very much logic. All we really say is, when you like a book, well, you can't like a book more than once, right? So if you try to like a book twice, don't fail, just don't do anything, right? And then reviewing a book is the same thing, but we do allow you to update the review content if the record exists there already. And that's really all we're going to be testing here. The database project is kind of even more simple. We only have 3 tables, and they're all very small. And I would say also, don't use these tables as an example for good entity design. These are very simple just to showcase test containers. Really, all I've done is put a primary key on them. I don't even have foreign keys on them. And I think they only have three or four columns each in them. And the way I kind of structured this project is I have 3 testing projects, and we'll go through them one by one. They each build on the other. So we'll start with 1, improve it a little in 2, and then improve that a little more in 3. And this will not be, this assumes some integration testing knowledge, so we're not going to go over how to do everything about that in C#. But I think a pretty common way to do your integration tests is you'll make a custom web application factory, something with that. And in here, we remove our actual production database context, add our test database context, and we'll go over this more. And then in your tests, you'll use an iClass fixture, which just says, hey, whatever is an integration test factory, do the setup once for the whole class. Don't do it once for every test. Because an integration test, the setup is usually a little more expensive, and we just don't really gain anything by it. Right? It just takes up more time. So that's what we're doing here. And the important thing we want to look at here is that custom test factory. So here's our test containers line that I showed from the slide earlier. And this is all we need. This will spin up a container. And you can put other stuff in here because it's a builder pattern. So I can say with database, with password, there's a whole bunch of stuff in here. You can give it a specific image you have. You can give it a different wait strategy to use so it knows how to know when the container is ready to be used. But thankfully, with test containers, we don't have to do all that. It has this concept of sensible defaults for the pre-made modules. So this PostgreSQL builder, we can find out, if I go to the source code for PostgreSQL builder and the test containers repo, we can see it will set these things whether I give them or not. So these values at the top here will be the defaults for those. So if I don't specify them, that's what it's going to set for them anyway. And for a test database, I really don't care what their username and password and database name are going to be, right? The only 2 things of note here are the port. One, on the Docker side, this will be randomized for every container so that you don't run into port conflicts when your tests run. And that's another thing that would be, you have to roll custom yourself if you're using Docker or something else. And the image, when you run this for real, I'm not going to do it for the demo, but you probably want to specify the image so you can specify the major or minor version of your database that production is actually using, just so you ensure parity. But really, this is all we need, and it will work. And then our initialize async, which is when this class starts up, we'll say, hey, start the container. And we can get the connection string out of that container to give to our test database context here. So cool. Let's actually see that in action, right? So this first test, pretty simple. Actually, let's go to the like book tests. We're saying if the book like doesn't exist, if that record doesn't exist in the database and we call this path, then there should be a record in the database afterwards of that book like, right? So let's run this, and I'm going to put a breakpoint in here just so it's easier to catch this in action before it closes down. And again, you will need Docker on your computer or the pipeline, the GitHub runner, whatever is actually running this. It is actually spinning up containers. I think I ran it and not debugged it. And I'll pull up my Docker desktop here. So here's what it's made. You can actually see the containers here. Oh, it wasn't done. I actually spun up 2 instances. So this is 2 test instances running. So it's really made 2 containers per test instance. So why did it make 2 containers is what I want to address. We see the Postgres one here, and then there's another one called the reuse container. We didn't ask for that one, but this is something TestContainers makes every time it runs. And it's called the resource reaper container. He's just in charge of, when the test is done, deleting all the other containers, and then he deletes himself as well. And if you are wondering, yes, this is named after the Ryuk from Death Note, because he's in charge of killing everything else. And if you look at the, doesn't matter, it's just fun. If you look at the Ryuk source code, they actually it keeps a dictionary of labels for the containers to know what to close down. It calls that variable the Death Note. So it is named after him. So let's let our test continue. Remove that breakpoint. And you'll see the Postgres one's closed down, and then Ryuk will delete himself as well. He's still running. Let me stop those just because I accidentally created 2 instances of the test. Okay, and that is a good example actually, because let's say something goes wrong and we don't hit our dispose async method in our web application factory. So this would be something you have to address in Docker. If you're using that, you'd have to go, okay, now I need to address cleaning things up because something happened. Your test process crashes, IDE crashes, something doesn't happen, it doesn't close right. So Ryuk still takes care of that, because the way he works is he establishes a TCP connection with the test process when that starts up, and all he does is hold on to that connection. And if that connection is ever severed, it gives it a few seconds to make sure it's not coming back. But if it doesn't come back, then it says, okay, I guess we're done, and it closes down all the containers and then himself. So even if something goes wrong, you don't have to worry about cleanup. TestContainers still takes care of all that for you. Now, we have a second test in here, which does basically just the inverse. It says if this book like already does exist in the database, then when we call the path, it shouldn't fail out. It just shouldn't add a second record. So to do that, we have to insert a record first, right? And then call this method and make sure there's still only one in there. So that's fine. Let's run the whole class, both the tests together, and see what happens. And we see one of them failed, the second one worked, but the first one failed. And the reason for this is they are both expecting one record in there by the end. That's what they're asserting on. But they also both insert a record. So whatever test goes second, there will be 2 records in there, and it will fail. So this is what we call state bleed between tests, right? And with integration tests, it's usually a little more difficult to reset this state. It's more expensive, it takes longer, it's just a harder problem. And ideally, we would like all of our tests to be run in isolation and together, and to not bleed their state all over the place, still just to work correctly. So normally there's a few ways to address this. You can try using transactions and your integration tests. It's a little more work, and that still has some of its own problems. You can try to reset the database yourself with some scripts or something, and that's usually slower. What I'm going to do is I'll go to my stage 2 project here. I'm going to use a library called Respawn, and this is by Jimmy Bogard, the same guy who wrote Automapper and Mediator, if you know those. More important to me is that we're both from Texas, so that's why I use it. This is also just super clean to use, and the only purpose this library has is to clear out a test database. And you don't need to really know the internals of how that works, but basically it does it super quickly by creating a graph of the foreign keys and then using deletes instead of truncates. So all you have to do is give it schemas to include that you want to wipe out and schemas to exclude that you don't want to, that you want to keep the data in. And in this case, we only have one schema, and it's the public schema. And it's about the same amount of effort to set these up. I create a respawner here in my web application factory. And down in my initialize async, I say, hey, respawner, create me a respawner. Here's the connection from my container database. And I'm using the Postgres adapter. It's got a few others on here. And I believe you can roll your own as well if yours isn't listed. But it's got those out of the box. We're using Postgres adapter. And please wipe out the public schema. And that's basically it. And now whenever we want to wipe it out, we just call reset async on our respawner object. And the way I do this is I just made this, as you can see, a public method on the reset, on the integration test factory. And I sort of bubble this up to my tests. So if I go to the likebook test again, I just assign him to a variable, right? And we use xunit's iasync lifetime. And you sort of need to know how xunit execution context works. So these dispose async and initialize async methods will happen after every test run. And these class fixtures will make it so that the setup in integration test factory only happens once for the entire class. So we're not going to go everything with integration test, but it does help to know how xunit works a little bit. And we will also change this in the next integration test project. So I just assign the reset database to a variable here, and then in my dispose async after every test, I call reset database, which will wipe the database out after every test. So it sounds expensive, but it helps to see it in action to show that it almost takes no time at all. We also get this initialize async method for free. We really don't need it, so we just return a completed task. So to test this out, let's just run the test class again and see what happens. And they both passed here. And that's because we have this, these are the exact same tests as before in the first project, but now we are completely clearing out the database between each test, right? So we can make some assumptions about what our database looks like. And you can still see the database with some initial stuff if you want to, and that will still work. But we do have a reliable state to go back to that's very quick to get there. So respawn is not, tied to test containers, but I think they go together very well and kind of a natural fit. And these review book and get book tests, I suppose I'll show them and run them just for completeness sake, but they're pretty much more the same. Review book tests are going to do the same thing, make sure there's a record in there by the end of it. And the get book tests, those pass the get book tests. I think there's only one test in here. He just says, if there's a book, then you should return him, right? And then the last test project here, we're just going to sort of clean things up a little bit, show you what I think are maybe some nice practices to really get a clean test project, right? So, cool. And I don't think I have changed integration test factory in this third project. He should still be the same. But I've made this class called database test. And this is, you can see he inherits from iasync lifetime, and he is implementing these methods now, right? And this is kind of just to keep things clean, keep everything in one place. Now all my tests don't have to each implement this. I'm putting the HTTP client and the reset database and the DB context in here, just because probably all my integration tests are going to use this, right? It's a common shared thing. And now my tests, if I go to the likebook test here, can all just inherit from database test, right? And they'll still work. Now, the other thing you may have noticed is that these are using collection fixtures here. So collection fixtures is an XUnit thing. The way XUnit works by default is that it just considers each class its own collection. And how XUnit runs tests is within a class, within a collection, each test will run sequentially, not in parallel, but collections will run in parallel to each other. So this may matter for how you want to run your database tests. Here I'm showcasing it just to show you can just fine run multiple containers for your tests, and there's not really any problem with this. And it's probably good to know, because if you just stuck with I class fixture, eventually you might have, I don't know, 100 test classes maybe, and you're spinning up 100 containers in your pipeline. That might be a little much. I haven't tested that far, but you can let me know. In that case, you might want to use collection fixtures. You can say, hey, we'll just share, 10 collections throughout all the integration tests. And they spin up 10 containers that run in parallel, and it just uses less resources overall, and it's still just as fast. So here I've made 2 test collections to sort of show how this is working, 2 test collections across 3 classes. And the way these work is you just say, you need a class for the database collection. It doesn't need to have anything, as you can see. And then you tag it with this collection definition attribute and just name it whatever you want. And then the actual test class, you tag it with collection. So it is now part of database test collection. So I've done that there, and I've done the same thing on these 2. I just made a second one and tagged them with the second one. So all in all, we have 2 collections running for our test suite. And let's go ahead and run the whole suite so we can see that in our containers. And they'll probably close down pretty quick, but I think we'll be able to see them. So there's Ryuk, and there's our 2 Postgres containers. They're just running side by side. They'll close down in a moment, and then Ryuk will close down. And I think, at least for me, the first reaction when I saw this is cool, but how fast is this? And in my experience, it's pretty darn fast with respawn and everything. There seems to be some initial overhead spinning up the container, which is not surprising, but it kind of seems to depend on how much my laptop is doing at any given moment. So I've seen that overhead. You can see these tests took about 7.5 seconds for 9 tests and 3 containers. I've seen that overhead be less than 2 seconds, and I've seen it be like 5 seconds. So I still think that's pretty good for spinning up multiple containers, managing them for you, destroying them at the end. And I believe Docker even comes pre-installed on GitHub action runners now, so you don't have to worry about that. And obviously, I'm using EF Core for this example, but if your team is using something different, maybe you're using Dapper or ADO.NET. Hopefully nobody's using that still. It just works. As long as you're using a database, it'll work with it, right? So EF Core is in the name, and SQLite is in the name. But really, the problem is you're talking to a database somehow, and it's not your production system. So remember that. OK, so that's the coding. That's really the meat. That's how TestContainers is working. And I'm back to the beginning on me. So there are 2 things I want to talk about explicitly, because I think there's probably at least one person in the room thinking, does this work with Podman? And it depends, from what I've seen, on the language you're working with, because it's open source. The different language versions are maintained all by different people. So for instance, with Go test containers, I know for sure Podman does work. And in theory, it just needs any Docker compatible API, so it should work in .NET as well. That being said, I don't know if there's some kind of support that it needs explicitly to be added, I have seen a GitHub issue where one guy said, well, I'm on Mac, and I just had to add an environment variable, and Podman worked. And Atomic Jar has also since acquired TestContainers, so I don't know if that plays into it at all. But theoretically, it should. It should be fine. And reusable containers. This is a pretty cool thing, in my opinion. This is an experimental feature of TestContainers. But basically, when Ryuk would normally spin down the containers, it doesn't. It just keeps them around, and it reuses them on the next test run. And to do this, it's pretty simple. You just say where you would create your test container, which is here. Before you do your build, I think there's just a with reuse, and you set that to true, and that's it. And you'll get reusable containers. I have not tested this myself, but I could see this being useful if you have maybe some very complicated and time-consuming test setup, lots of containers. Maybe you're setting up a Redis cluster or something, or maybe you have a base set of data that you don't want to be deleted from your database because it's a lot or something. I could definitely see that coming in handy. And just to recap, sometimes I walk out of a talk and all the knowledge walks out of the talk with me. So hopefully that doesn't happen. We kind of went over traditional options for what you see in integration tests a lot. It's not just SQLite, it's a few other things, and really the problem is as long as you're not using Postgres or whatever you're using in production, it's not the same system you're tested against, right? And even if it is, there might be maintainability issues like a real database, something like that. And talked about what TestContainers is, what it offers, how to use it. They saw it in coding demo, we saw it in action. And I have done a test with a couple hundred tests with TestContainers, and it didn't seem to take any longer. It still took, I think it was like 5 seconds to run a couple hundred tests using a container. So that spinning up and spinning down, really, it seems to be pretty seamless in my experience. And we also talked about Respawn, which is a whole separate library, but very relevant to this, where it will help you reset your database back to a clean slate so tests don't bump into each other, right? And you have that clean slate every run. And that's it. So this is the QR code again for you can find the repo and the slides here. And you can hit me up at all the 3 things listed here. And if there's any questions, I would love that. You can come up to the podium and ask. So, thank you.